Okay, I think we're ready to get started. Hi, everyone. Welcome. So glad all of you made it. Nice big room where everyone can get their own space. But I really appreciate everyone coming. Today we're going to be talking about how to build secure AI agents with Azure Functions. So as you can imagine, it's kind of all about what do we do with these AI agents, and then how does Azure Functions play its role in letting you actually build out these agents in your own organization. My name's Eamon O'Reilly. I'm a product manager on the Azure Functions team. And today I'm joined by Pim Zandi from Heineken, who's going to come up, as well as Ahmed Mansour, who's going to talk about some of the work they've done with Heineken and how they build out their AI solution. Okay, so first up, what is everyone here for? So the agendas kind of go into these separate parts. I think the main thing to think about is when you're trying to build AI agents, what role do you play as a developer, as an architect, as an owner of some part of your business in trying to build out these AI agents? And I think the main thing to think about is who has the knowledge about the systems that are going to make these agents powerful? And I think all of us know that a lot of the power of AI, and we've really seen it over the last couple of years, is because these large language models are really good at taking your intent and then generating the results and the knowledge to actually go solve that intent. But what they're missing was the ability to actually take action, and they're missing the ability to add in new context into those decisions that they're making based on what you're asking of them. And so what does that really mean? It means you have that knowledge in your systems. So if you have a CRM system, a support system, whatever system all you guys have been building over the last 10, 15, 20, 30 years, that is really what allows those AI agents to be powerful, is because they can interact with those systems. They can interact with the data that's in those systems. And that's when we talk about these tools and given the ability for the AI to not just take additional context, but also to take action. And so that's really what agents are about. And today we'll talk about how functions can kind of allow you, as the owner of those systems, you have the ability to understand what can I do that allows these agents to be powerful inside of the system that you guys build today. And so we'll talk a lot about that, and we'll also go into some unique capabilities of functions around MCP, around our durable functions capabilities, that allows you to really enhance what your existing systems are and make those available to those AI agents. Okay, so I think if you've been at any session, probably you've kind of heard about agents, you've heard about AI agents. I think everybody's been expected to think about what can they do in the world of AI agents. And even ourselves at Microsoft, that's one of the things we get asked, I'm sure a lot of you get asked, is I work on this system, I kind of own what happens in this system, how do I bring AI agents into my application and make it more powerful and more productive for either people inside the organization or the customers that are using your application? And so this AI has a whole spectrum of, initially it was all about kind of sending the right information to the LLM and then let it use its reasoning, its knowledge to provide really good answers. And that at the core of it is really what these large language models are good at. But when you think about agents, it's really about trying to bring the next step so that they can get context and they can take action. And I think that's where a lot of you guys are going to play a key role over the next few years, is actually bringing that capability to these large language models. So you're going to get those productivity gains. You're not going to get it, I think, unless everybody here and everybody watching is actually thinking about, I own these systems, what can I do to enable that as part of the agents? Okay, so the common slide we have around agents is, how do you leverage all of this Azure infrastructure we've built? How do you leverage all of this new AI capability we have in Foundry? And the nice thing about the way we kind of modeled a lot what we've done inside of Microsoft, and particularly inside of AI Foundry and Azure, is we've tried to unify how you can integrate with your data, how you can integrate with your agents, and then how these clients who are trying to consume that can take advantage of it. And so obviously Copilot is something that's been around for a little while now, gives you a lot of value. But what we're going to talk about today is really around how do you, as developers, as architects, as consultants, or whatever your role is inside your organization, how do you play that role in building out these capabilities and making them available for agents? Okay, so that's kind of at the high level. I hope we're all kind of set on, okay, we want to build these agents. There's an expectation we can get value out of all these large language models. But what does Azure Functions do to actually make that easier for you? And obviously, it's a big ecosystem of capabilities around what you can do with agents. But from the functions perspective, we really drill into three things. And the first capability we offer is what I would call real-time retrieval augmented generation. So real-time RAG. And why is that important? So a lot of your data, as you know today, it's often siloed into different systems. And then when you try to do natural language search against that, semantic search, it's almost impossible because the data doesn't really understand what natural language is. And then it's also not in one single place where you can get that value out of it. And so a lot of work has been done over the last year, probably by some of you guys, by a lot of people, of bringing all of that data into a unified vector store, like AI Search, like Cosmos DB, so that now you can work with that data through natural language, through agent calls. And so one thing about functions is, when I call it the real time, is we are an event-driven architecture. If any of you guys have kind of used functions, you know, what we really excel at is the ability to scale really fast, down to 0, up to hundreds of different nodes, but do it based on events that are happening. And so you can imagine as data is getting entered into your systems, like your CRM systems or your product catalog systems, or it's coming through an event hub for IoT, whatever that data is, you want to take all that data and be able to send it into your vector store in real time so that you can get access. So that's one kind of thing we'll talk about today is real-time RAG and how you could use that inside your organization to try to bring all this data and make it available through semantic search for these AI agents. The second thing that's probably the most important thing when you think about functions is agents have the ability to call tools. One of those tools they call are functions. And so what are they using those functions for? And it goes back to what I talked about is that's where the power of agents comes in, is this tool calling. So they need to be able to reach into your systems and be able to take all that work you guys had done to expose those through APIs and then be able to call action on those or retrieve more information so they have context on what they're trying to accomplish as an agent. And so Azure Functions has done a lot of work to make it easier for you to expose all of these capabilities out to whatever agents you want to build in your organization. You have the knowledge of your systems. People are trying to build out these agents in your organization. How do you work together in a collaborative way so you can expose your capabilities and enhance your business applications? And then the last thing I'll talk about when you think about Azure Functions is we have this great capability in Azure Functions called durable functions. And I'll talk a little bit more about that. But the concept is when you're trying to build out agents, you're trying to call these function tools, oftentimes they require state management, they require orchestration, they might be long running. And so naturally, you think about serverless, it's often difficult to implement that. But with durable functions, a whole range of scenarios now open up when you're trying to build out these function tool calls, as well as when you're trying to build out your own agents. And so obviously, the one good thing about functions is no matter what language you develop in your organization, if you're a .NET developer, you're a Java developer, you're a Node developer, or a Python developer, you can basically use the same capabilities and bring all that knowledge forward when you're building out these solutions in functions. Okay, so now that kind of the landscape is there, let me talk a little bit about one of our customers we've been working with and kind of showcase what they've done as they've built out their AI solutions and kind of show a little video here to introduce you to it, and then we'll invite Pim to talk a little bit about it. So here is Heineken, one of our great customers.
At Heineken, we've been brewing connections for over 160 years, bringing people together one sip at a time. Today, the same spirit of connection fuels how we innovate
We are transforming global operations with smarter logistics and tighter collaboration. To make that vision real, we imagine a single intelligent interface, like a digital colleague that understands our teams, speaks their language, and helps them move faster.
But turning that idea into reality meant solving a challenge. Our data lived in silos, scattered across systems and teams.
Built on an AI-ready Azure foundation, we developed Hoppy as a metaphorical bottle opener to unlock knowledge stuck in the organization.
Acting as an orchestrator, Hoppy coordinates specialized agents to deliver insights and streamlining tasks that once required multiple tools and teams.
Azure AI Foundry connects to platforms to automate our workflows. Azure AI Foundry Agent Service helps us build autonomous agents and connects with Azure AI Search.
These agents are connected in a multi-agentic system using models in Azure AI Foundry models to reason and refine responses.
Azure Cosmos DB stores conversation history, user tokens and profiles so Hoppy can learn and provide better experiences. And we use Azure Functions to orchestrate processing across all the different knowledge sources that feed into the RAG system.
What used to take 10 to 15 minutes now takes just 5 to 10 seconds.
Hoppy will soon join Teams calls, boosting productivity while keeping collaboration engaging with 99.9% uptime.
By building on Azure, we're not just delivering answers, we're unlocking the full potential of agentic AI to connect people.
Awesome. So I'm going to welcome up Pim to the stage from Heineken, and he's going to talk a little bit about that great solution they built. Here, Pim, I'll let you have this as well.
Yes. Good morning. Great to be at Build. My team is responsible for Hoppy, it's one of the products I'm responsible for, and I would like to tell you a bit more about the journey we did. So how did we start? And actually, as almost every good idea, it started at the bar. Our general manager from Vietnam and our CEO was sitting there and said, like, hey, how cool would it be if we could chat with a bot or something else, and we could know what the sales from this bar were yesterday, or even today. And with this idea, they came back to Amsterdam and asked my team, can we do something with that? And we liked the idea, and we said, okay, but before we really start this GenAI case, let's maybe interview a bit more of our operating companies and on C-level and check what they want. So there were 4 interesting points during all these interviews we gathered. And one is, of course, as you also in the video, our landscape was quite scattered. So the data was sitting in different environments, platforms, and reports. As a GM, sometimes you had like 10 or 20 reports, BI reports, where you could find certain information. Also, what we noticed is a language barrier. Most of our operating procedures are in English, and that's fine for the MT-1. But below, if you go deeper into the organization, especially for more operational roles, in different countries we operate, it was quite hard to understand and translate these to the local language. And also what was quite interesting coming from our finance directors, commerce directors that say, hey, sometimes I just want to see on Sunday evening, gather some insights on how we did last week about the revenue. And I don't want to bother my business analyst on a Sunday evening, but I want to prepare the documentation myself. So can you help with that? And the 4th pillar was like the 4 pointers coming out is like, I don't want to go always to a report to check what has happened, but I just want to get these insights right away. And with these points, we built actually 4 pillars. And the first one is knowledge management. And knowledge management, what we did is we gathered all kinds of data we have in Heineken in one index. So we connected with different platforms, with like SharePoint, but also Calibra. And we index all the data we have and validate. Because what we see sometimes with Copilot, there can be an old document in some SharePoint, and it suddenly becomes a source of truth for a lot of people. So we did a validation process before it enters our index. The second pillar is chat with your data, what is really important for us. So there we connect with SAP, with Azure via Databricks, and also Calibra is on the way for process mining. And the really cool thing is that we can combine the knowledge management part and the chat with your data. So what we do, before we send a question to the chat with your data part, we enrich the data. So, for example, all our KPIs are documented in Calibra. So we use this knowledge. So if someone like mentioning a certain KPI, we enrich and tell the platform where the KPI is about. So we can get a better answer back. And the other thing is what I think really the magic happens is that we can combine knowledge management and chat with your data. So for example, we see, for example, you're in commerce director, you ask, hey, what is my revenue and what is driving it? For the revenue part, you can just go to SAP, get the data there and give you a nice table or a chart. But for the driving part, there we go to our knowledge management index and check what is driving it. So we have like Nielsen data and other research data there, and we check what what could influence the results from last month. And we take this together and send it back to the user. And this saves a lot of time for our users. So something before this question, if you ask it to a business analyst, it took around like maybe an hour, 2 hours to get all the data, get it together in a PowerPoint. And now it's just a matter of seconds. And that's a huge improvement for us. The third pillar is about event-driven actions. As you saw, like what is really a struggle, what we want to avoid is that our users go to the reports every time to see if the market share maybe changed or they reach the cost center, the budget. And we really want to go directly to the users. So that's something we're now developing. So so our platform, Hoppy, will reach out to the user in case you almost reach your call center, or maybe when a process is stuck, so maybe an order is blocked, then we also will reach out to the user via our platform. And the fourth pillar is accelerated processes, and there we really want to help users. So there are a lot of agents coming in, and one of the examples we're working now on is with ServiceNow, is in case a user is stuck with the knowledge management part, so we can't answer this question, we will create a ticket for them automatically in the same Teams interface, and it will go to ServiceNow and to our support team. And this all works via Teams. So we use Teams as an interface. We really position Hoppy as our digital colleague, what is available on Teams, and that's why we're there. And one other thing is what we now also developed is, for example, a podcast. So every Monday morning, we also, with GenAI, we gather the data from Azure, we create a podcast with GenAI, and publish it for our commerce directors and other directors. And with this, I think it's nice, but I think we should go now more to the tech side of it. And I want to invite Ahmed to show a bit more about how we use Azure Functions. And as we say in our team, don't worry, be Hoppy. And hopefully you can show a bit more about our architecture. Thank you.
So thank you, Pim. To bring these 4 focus pillars to life, namely the knowledge base, the chat with your data, i.e. RAG, event-driven actions, and accelerated processes, the development team needed an approach that was both agile and extensible. And that's why in this solution, which I will begin talking about, combined a fusion of both low-code and pro-code components. So the Copilot Studio, for instance, creates this directive dialogue manager, which is good for running quick bot prototyping. However, the team also needed further customization and integrations that were not yet possible out of the box. And so that's why components such as the Foundry SDK, GitHub Actions, and Visual Studio Code were necessary for these additional customizations. Now, the heart of the solution is AI Foundry, having the orchestration layer. And in Foundry, these models existed from the model catalog that the applications can leverage to be used, right? However, these models don't inherently understand enterprise data. And so this is where RAG comes in. So in order to achieve this, these models needed access to enterprise data. We indexed these enterprise data using Azure AI Search and allowed these models to retrieve and reason over Heineken's internal data. And so with that, providing these capabilities. And at the other side, there's a lot of other capabilities that they enabled within Foundry, but it's too long for this session. However, things like evaluations, tracing, content filtering, and even content understanding capabilities within Foundry were there. However, the main focus of this session is, if we zoom in on the right-hand side, this is where the event-driven actions are enriching the knowledge base. And so updates on the products table, for instance, in SQL Server, or SharePoint documents or even signals coming from internal APIs, they will in turn be populated back to the index itself. And so you have the latest information. The model has access to the latest information to use. Now, I want to zoom in on the scenario where they used real-time RAG and just blow up a little bit that right-hand side. This is just an example of one of the sources. In this case, you've got functions. The function app, first of all, you would enable system-managed identity. So security is very critical in this case, so we don't want to have any keys available or exposed, so system-managed identity is enabled, and both connections are established with the landing blob storage and the SQL Server. Change tracking is enabled on the database and the table, and provided to that specific system-managed identity for the function. And in this case, the SQL Server is connected. Functions is using a SQL trigger input binding in this case. So it is listening to the changes on the SQL Server. What happens here is that this SQL trigger has an extension that uses two main variables, which is the polling interval and the batch size. The polling interval is configurable, and I'll show you how that looks like. It's really all the way from 1 second to a day, really dependent on the business. However, as it listens to changes, it is executing micro batches to process this information and then transforming it as well. So in this case, for Heineken, they were also transforming the changes that they were retrieving from these micro batches and then storing them in blob storage in a format that can be extracted by the indexer schedule. So I want to switch over to my machine and so I'm already on the function app, and I'm just looking at the log stream at the moment. I will just refresh this, but it's really, I have the SQL Server connected, and the change tracking is currently enabled on insert, updates, and deletes. So anything in that case will be tracked and stored in a table, change tracking table on SQL Server, but also the SQL trigger will be notified by that. So I just want to capture. So let me try to run that one more time. So what happens here is that in the log stream, I will see that there is 20 records that have been captured as detected as changes, but at the same time, I also have that those micro batches that have been captured, they will also create a new entry as a JSON string in the blob storage container that I have access to. So it's quite simple, and that's really the essence of this demo, is really just to show you that usage of the functions here is very modular, and it integrates with their entire CI/CD setup. I just want to show you how that looks like. It's basically that SQL trigger input binding that they've used. They're capturing log diagnostics along the way as well, but also setting the configuration context could be using the environment variables on the function app in Azure and really not storing any information on the local settings. That is really optional just for testing purposes, so it's also there. And also logging alongside from really the beginning all the way to is the storage container and is the storage blob configured correctly in the environment logs. And finally is just storing that information in a unique value, so with the actual date and settings. This is an example of what they're currently running at the moment. It is picked up by the indexer, but it's not real time. So I also have an example here of what that would look like. Instead of using just the output bindings to the blob storage, you could also use a connection to push data directly to the Azure AI Search Index. And with that, you have a full end-to-end real-time RAG application. Finally, it's just you would also, the polling interval, like I mentioned, and the batch size are configurable. So this is really up to the business how this is defined. So just to sum up, we talked about knowledge management and how they have it, chat with your data, RAG applications, and event-driven actions, how Azure Functions can really complement that whole story. And with that, I hand it back to you, Eamon.
Awesome, Ahmed. Really nice, really simple, but I think really powerful when you think about how do I kind of build out these large systems, but you kind of want to make them modular. And one thing about functions is you've seen it there with the event-driven architecture nature. Because you can basically build your app in an async way, it does allow you for having really high scale capabilities and let each of the components scale independent of each other by kind of embracing event-driven architecture, which is what you saw there. Okay, so one of the things we talked a little bit about at the beginning was how do you secure all these agents? And when you think about agents, agents is a large kind of capability. You're including maybe Foundry, you're including some data, now you're including functions. And the way I think about security with AI agents is it's really not that different than what you're expected to do today when you're building your own applications and exposing those out to your client apps. Maybe they're web apps, maybe they're Teams apps, maybe they're their own clients. But you want to embrace the same capabilities when you're building out these agents. And the one thing we want to talk a little bit about is if you're going to expose your systems out to agents, you really need to think about a few things that you want to apply on top of these tools that you're building. Obviously, security and Foundry has a whole set of capabilities. You saw probably some of that during the week. But I'm going to talk a little bit about what you do with functions. So the first thing to consider, obviously, is if you're going to give them access, make sure that you can bring them into a network that you have control over. So when you think about a virtual network, it may be talking to your on-premises systems, it may be talking totally into the cloud, but bringing in virtual network and taking advantage of all of the Azure capabilities around isolation and the ability to apply policies and rules, that is something you should definitely think about before you even start to expose any of these tools. I know a lot of us, I do it the same, is I just want to get the functionality out, I want to get the capability out, but you really want to think about security beforehand and make sure the systems you're building, the integrations you're building, they have the ability to do networking if needed, because that will give you that one extra layer of security. And I think all the security guys in here as well will give you some extra praise if you can kind of build out your app so it has security built in to start with. I think the next thing, which if you're familiar with Azure Functions, you're familiar with a lot of Azure capabilities, is we spend a lot of time making sure that customers can apply compliance, can apply auditing, can get visibility into what's going on. And as you start to build out these functions, these capabilities, and expose them out to agents, you want to apply those same best practices. And the good thing is because you're leveraging kind of the same services, hopefully you don't have to learn a lot. You might be applying these already in your apps. But when you think about agents, because a lot of them are going to run by themselves, they may not have as much visibility into what clients are calling them. You want to make sure you build in all of this auditing, all of this observability directly into your function tools themselves, and you'll have control over what happened afterwards. And then the last area for security is really about kind of identity and secrets management. You saw Ahmed talk a little bit about what Heineken were doing to try to remove secrets from their environment. And one of the things we've been trying to make available inside of all of the Azure experiences is to really bet on not having to use secrets unless you absolutely have to. And if you do, make sure they're in Key Vault so that you can secure them. Because if they start to leak, I think everyone knows it's very difficult to actually get them back out and redo your app again. So kind of the recommendation is use managed identity. If if you're trying to communicate with other services. The second thing is, we have support with Entra. You can automatically configure your endpoints so that they have auth built into them. So it's more of a, if you're going to secure, you want to secure every single part of your larger agent ecosystem. And on the function side, take advantage of all the features that are built in. They're available in all the plans. You can use them however you want to use them, but I would definitely think, okay, what do I need to lock down this thing before I ever expose it out so an agent can call it? Okay, so that's a good transition into function calling. So we talked a little bit about RAG, which is great, gets all your data in one place. You now have semantic search on it. But how do you actually build out functions and expose them out to agents so that they can use them in your organization? And that's really what we talk about when with function calling. Okay, so when you think about function calling, there's lots of ways to allow function calling. One is you can just call the function directly when it's available. I will talk a little bit about that. We have an event-driven async way to call functions with the agent service in Foundry. I'll showcase that a little bit. But one of the new things that came out, I'm sure a lot of you guys heard of this, is there's a new protocol out there called Model Context Protocol. And what it really means is allows you as developers, you as architects, to be able to expose these systems out to the agents in a standardized way. Because one of the challenges I think a lot of us have seen as we try to build out some of these agent solutions is it actually became very difficult and you had to collaborate very closely with all the different systems in your organization in order to try to get an agent to work. And what the MCP protocol allows you to do is basically you can now have a standard way to advertise out what capabilities you're willing to offer to the agent. And those are expressed through the Model Context Protocol. They're basically like APIs. The agent can understand that. It can retrieve all the capabilities you're offering, and then it can call those automatically in a standardized way. So that's really what MCP. There's nothing too magical about it, but it really solves that hard problem of where you have agents trying to integrate into all the different systems, but they have no standardized way of doing it. Now you as a developer can say, I'm going to build out my set of capabilities, and it doesn't matter what agent gets built. There might be one agent for your product catalog, there's another one for your customers. All of those agents now can point to what you've offered through MCP, and then they can call you as long as they have the right security. Okay, so I think maybe some of you, but probably not a lot of you, have heard that we launched basically MCP support in Azure Functions in public preview for build. And so what does this mean for you as a developer who says, okay, I want to be able to embrace this, what do I do? So what we've offered is, inside of Functions, we have this built-in programming model that really allows you as a developer to very easily build out your integration into different systems. And so we have a binding that allows you to define that you want these functions to be exposed as MCP functions. And just with metadata, you can now expose those out to any caller, any agent who wants to use them. The other thing we offer is, I talked earlier, is the nice thing about going with Functions is you don't have to retrain as a developer, or if you're in charge of developers in your organization, whatever language your organization already uses. You're a .NET team, you're a Python team, Java team, it doesn't matter. Functions supports all of those languages, and so does our bindings. And so you can use whatever language you want and expose that out as an MCP function that can get called by any agent. And then the other thing I talked a little bit about, which I'll go into some more detail, is some of these functions could be quite complex. They might be long-running. They might have a lot of other capabilities they need to do, but you can take advantage of durable functions inside of the same MCP bindings that you've defined for your functions. So that's kind of the developer experience. Like, how do I, as a developer, figure out what I want to expose? How do I standardize it? And how do I build it out? But the other thing to think about is, okay, what does the runtime experience look like for these MCP servers? You may not know which agents are going to be calling you. You may not know how popular your tools are. But the one thing you want to make sure is when you actually build this, You can host it in any environment that you want to host it. So you might be hosting it along with containers and container apps. You might want to host it inside of app services because you've got a lot of web app clients. You might want to host it just in our standalone serverless plans, like flex consumption. But all of those runtimes can basically stand up and host these MCP servers. And then scale is one of those sometimes it's hard to determine. I know, years ago, and even now, like one of the things we used to always think about was, okay, how much do I have to provision? How much is this app going to cost me? And we spent a lot of time trying to figure out, well, it depends on how much usage. We're not really sure. And the one thing that Functions gives you in a lot of our serverless solutions is you get that dynamic scale built in. So it'll go from 0 when nothing's being called all the way up to hundreds of instances with different sizes of instances if you want, from 512 now up to 4 gigs. We can have concurrency inside of those instances. So you get all of this really fast scale inside of Functions when you're trying to build out MCP and expose it. And I talked a lot about security, but I think it's one of those things that we don't want to ever forget, especially as we build out more and more agents. We may not have as much control over who's going to be calling these MCP tools. Previously, a lot of you might build out your solutions, and then you'd kind of know who the clients are. There'd be 1 or 2 clients, and you can kind of control how that whole system works. In the agent world, you could imagine where there's dozens, maybe hundreds of agents over time that are all doing their thing, but they need access to your systems, and they're going to be calling these function tools through MCP in order to be able to deliver that value. Okay, so I'm going to show a little bit about how this works in code a little bit, try to highlight, if you want to get started, how you can get started today and start to build this out and start thinking about what are you doing inside your organization. Okay, so the scenario I'm going to build really quick is it's going to build off this real-time RAG stuff we talked about. So you can imagine you have a support system in your organization. It's bringing in all these support cases, but you want to make all of that support data that's all over the place, perhaps, available through semantic search. And then you can expose that to your clients so that they can, customers maybe could query, they're a part of it. You could have your support agents query it. But you want to bring all that data available so you have that natural language interface into the data. So once you've got all that data in, so that might be one thing you're doing inside of your organization. But now you want to expose it out to an agent. So now there's a support agent that you're going to build inside of your organization. And that organization needs access to all of that data that you just brought in. And how you can do that is by using MCP in Azure Functions to expose that out and allow those agents to call into it. Okay, so with that, let me jump in real quick, and I will show a demo. Okay, so hopefully this looks okay. I will zoom in on some of the important parts. The first thing I'll call out is I have this running locally. So this is all running VS Code. This is Azure Functions, as you guys are familiar with it. Our host is open source. It runs identical on your local machine than it does in the cloud. So I'm running this locally. And you can see I have a couple of HTTP endpoints, which ingest data, and then I can prompt to ask questions of the data. And I also have this new thing I'll talk about called Get Support Information. And you can see it's of type MCP tool trigger. Okay, so what does that mean when I try to do something with my data? So the first thing is you want to be able to ingest this data in real time. So you could be ingesting this data, maybe it's through a webhook, and you're calling it continuously to ingest data. Maybe your data is showing up in blobs. Maybe it's showing up in SQL, like you saw with Heineken. It doesn't matter where this data is. You want to be able to consume it and send it into, in my example, I'm using Cosmos DB for NoSQL and their vector store that they have, which is awesome. There's a bunch, hopefully, of announcements you guys saw during the week on what Cosmos DB is doing in this space, but it's really powerful. So let me just send a request. And what this will do is it will call into our Azure function locally and try to run the data or import that data into the system. So let me just show you what that looks like. So within a few lines of code, you can basically see what's happening here. So this is the whole code I have. So I'm just calling ingest data. Oh, there's the response. It already ingested it. And this code was called. And all it does is it literally takes the text, the content in. And what we do is now is when we return it, we have this binding. So what I'm using is our OpenAI triggers and bindings in Azure Functions that has support for integrating into vector stores. So we can integrate in with AI Search. We can integrate in with Cosmos DB for NoSQL, as well as MongoDB, and for Data Explorer. And what you'll notice is just through config, we can take all of that inputted data, and we can do all the work of chunking up the data if needed, creating embeddings with the model as needed, and then storing that into that vector store so that it's now available for any clients who want to perform search on it. So all of that happens through the power of this one binding here. So you can see here, we're basically saying we're taking in the raw text, we're taking in the content, I want to send it to Cosmos DB, I have a container called RAG, and the model I'm using from OpenAI is all defined outside of this inside of my local settings. So just with that small piece of code, I'm able to ingest all of this data. So, okay, so now I have it ingested, and you can imagine this is happening in real time across all your systems, and you basically only have to define one of these bindings. Obviously, all of the SDKs you might want to use, all of the different frameworks out there, they all work great inside of Azure Functions. Okay, so I'm now going to ask a question. So what is support incident 3455 about? Since I just ingested a bunch of stuff, let's see if we can ask questions about it. And that was fast. So it's already back, and it's talking about this data. So now this data that we've imported all across your organization, you can now query through any clients you build. You might have a chat client, a web client, Teams. All of this data is now available for people to ask questions of, and you can imagine your sport agents using it. But what happens if you want to build this as an agent? So now an agent that's working inside your organization also wants access to this data. So you want to expose out this function and make it available, and you can do that through MCP. So let's see how that works. So right at the bottom here, I have this new thing called MCP tool trigger. So that is that configuration in Azure Functions that makes it easier for you to define your function and expose it out as an MCP tool. And again, all this is doing is it's doing exactly the same thing my other HTTP API does. It's going to take the text, it's going to do a search against all that data we imported, and it's going to return the results. So the whole function is that. So this is that get support. So just with those few lines, we've built an MCP. We're able to query all of the data inside of our system, and we can return it back to the agent who wants to do a task. So let me kind of run this real quick and see what that looks like. Okay, so I'm going to pick one here that's running up in the cloud. And I'm going to start it. So this is being hosted up in Azure Functions, and then I can basically ask questions of this. So I'm in agent mode, as you'll see inside of here. Obviously, any agents you're building, once they communicate with the same MCP endpoint, you'll get the same capability that you see here. So now it's saying search text, get me the latest information on support issue 3455. You can say I only want to run it for this session. You can configure how your agents you want to run. For VS Code, this is how they do it. And then I'll do continue. And now the agent, basically just by configuring this endpoint that's hosted in Azure, can now get all the results. And you can imagine it's sitting there doing work for the customer or for the support professional and has access to all this data as it's built up its knowledge to try to solve what's going on with the customer's issue. So all of that is exposed just by using Azure Functions. And the one thing I will show inside of here is make sure when you build out your solutions that they use networking, they use identity. So here you can see everything is managed identity, everything has a network, everything has a private endpoint talking to Cosmos, talking to OpenAI, talking to blobs. You want to kind of build this up as you can when you first start, so you know you're in a very secure lockdown mode. as you start to expose out these capabilities to agents. Okay, so let me jump now to the next demo and talk a little bit about what that looks like. Okay, so we said there was kind of 3 core capabilities in Azure Functions to help you build agents. One, this real-time RAG. One is function calling and enabling that to come out through MCP. And then the third is taking advantage of durable functions to build out these complex tasks that you might have inside of your system. And I won't talk to all these different flows we have inside of here and these patterns that you can use. But think about, you're trying to build a function, you might need something that's long running. You might need something that can aggregate multiple functions together. You might need something that needs approval inside of the function by an external person. And so anytime those patterns, you might have a long-running HTTP. Anytime those patterns you face inside of your function, I would default and look at Azure Functions with durable functions as a way to solve those. And they might become more important in the agent world because agents typically, they're kind of, well, one of the goals is that they can often run in the background and start to do work for you without you having to prompt or interact with it. And so those agents might want to do long-running tasks and make calls that are long-running. So with durable, you can provide all of these kind of patterns to those agents on top of what systems you're trying to expose. Okay, so there's kind of 2 patterns you'll see with function calling. One was, I showed one very easy there inside of MCP, but that one where we were calling in to get support information was just using a regular function, called some data, returned it, everything's nice and simple, fast. But you could also, when you call that MCP tool, it could actually kick off a durable function orchestration as well. And this might be where that function that you're exposing, it requires a lot of work. It needs to go collect a bunch of data, it needs to aggregate a bunch of data, it might fail on halfway through some of these systems, it might need to retry. All of those capabilities are available inside of durable functions, and they can be available inside of those functions that you just exposed inside of the MCP. There's also another way to call functions that kind of promotes the whole event-driven architecture capabilities of agents. And one of the things we announced at Build was GA integration with the Azure Foundry Agent Service. And so as you think about the agent service that's in Foundry, if you look up, one of the tools they have is the ability to call Azure Functions. And so you can specify Azure Functions, and when you do that, it basically moves all of the work that normally happens on the client. If you remember in the last one, basically the LLM will say, oh, it looks like you need to call this function to complete the task. And the client was responsible for taking that and then calling it. With our integration and event-driven nature with Agent Service and Azure Functions, all of that orchestration and calling now happens through the Agent Service, and it happens in an async way, so it can be long-running if you're trying to build that out. Okay, so let me jump in real quick, and I'll show a little bit of a demo here to give you a flavor. If you're trying to build this, what would it look like? Okay, so I'm going to kind of first of all show you, it's going to be querying across a bunch of like GitHub repos. So what I'll do is I'll go to a simple static web app that we have, and I'll just visit the React, and I'm going to ask to give me some issues. Maybe I'll do the 12 hours. So what I'm doing here is I'm just going to send and call an Azure function, a durable function, to say, I want to know what are the issues in one of these orgs that's up on GitHub. And these orgs could have dozens, maybe hundreds of repos. So I want to be able to fan out, collect all these different repos in parallel, and then aggregate all of that data back, and then be able to give it back to me automatically. So if I look at that in the code, I'll call out a couple of things that you'll want to be interested in. So last one, here's one in Python. So I mentioned this function calling and the ability to call something async. So what you'll notice here, I'll maybe zoom in just a little bit. You can see here I'm creating a Foundry agent inside of the code. But one of the things we talked about was when you specify the tools you want to call, you can now specify a type called Azure Function. And when you specify a type called Azure Function, what happens is you do the normal thing of like you can specify what the function's capable of doing. So this scenario, I can get GitHub issue summaries, I can ask for the org, the repo, and the time. And what's going to happen is when you send that question I had over to the large language model, it's going to try to figure out, does it have knowledge about those things? Nope. Okay, is there a tool available that I can use to actually answer this question? It's going to say yes. And, okay, what are the parameters, the properties I need to fill in to make that tool call successful? And it's going to give me the organization, the repo, and the time. And so what's happened here is you've just specified it normally, but using bindings, input binding, output binding, you can specify all of this communication is going to happen through storage queues. So the agent service is no longer going to return back to the client and say, you go call the function. It's going to call the function by putting that function information on a queue. And then the nice thing about Azure Functions is we already have the ability to listen to queues. So we have a queue trigger. We will pick up that information, and we'll be able to send it back directly with the response that we want to give it. So all of this is available inside of Azure Functions. And you'll see here, here's the queue. We'll get the message, and what we're doing then is we're just going to start an orchestration. And so this is where this Power Durable comes in to start that orchestration. And then all of the normal stuff you would expect about orchestration is available. You can do fan out, fan in. Any of those patterns I showed you are now available by just specifying the code here that when you specify this trigger, you want it to be able to start a client orchestration. And then you just write code like you normally would for all these activities, and you start to work your way through all the different scenarios you're trying to build out. So again, a very simple type solution, but very powerful. Because what you've done now is you've kind of moved a lot of responsibility away from the clients to make these function calls. A lot of times it might be a good thing, like that's where MCP can come in. But if you want to do things in an async way, then there is native integration where you can take that responsibility away from the client and have the agent service itself do this orchestration with Azure Functions. Okay. So the last scenario I'm going to touch on real quick, there was actually a demo, I think, before this session where it was touched on, was that durable functions capability we talked about and all of those patterns. You can imagine when you're trying to build out your own agent, a lot of times you already know what your business process is. You have a deterministic thing in your mind of what your agent should look like. What capabilities are you trying to offer out to your end users? And so one of the things we offer inside of Durable is all of those patterns, you can use them to build out very sophisticated solutions that might be calling other agents to perform their own tasks. And the reason we call it like deterministic or it's directed is when you use Durable, you can define how it begins and how it ends, and then you can basically call into agents to do some work along the way. But the nice thing about it is you'll know when you call the agent, when you get a response, all of that orchestration, you have full control as a developer on how that's going to work. And so this is one of the powerful things that kind of directed or deterministic workflow agents give you. And so if you're trying to get started building agents, you have an idea in your mind around what I could do inside of my business. One good approach to think about is, okay, let me define that process, that end-to-end, and then leverage Durable's functions capabilities to author that scenario out for you. Okay, so let me do the last demo real quick. And I will finish up. Okay, so back to here. Oh, there was the results of my GitHub issues. So they all came back. Okay, so this one is basically that travel solution I showed on the screen there. Again, it's a static web app. Why not? And I'm going to fill in some questions about what I want to do, and I'll basically say I'm looking for a trip to Ireland and the West Coast, and away we go. Okay, so you can imagine that you kind of know you want to be a travel agent, you want to interact with some end users, but you need to do some orchestration in the back end. You want to call other agents to do work. So all of this can be defined inside of Azure Functions. And if anything fails along the way, so you make a call to some agent service, it succeeds, then you call another one, it fails, you don't want to have to redo all of that again because you're no guarantee that you might get the same response back from the LLM that you did the first time. And so the nice thing about using durability, it has built-in resiliency. So if anything fails along the way, it's going to replay everything that happened so far, but it'll only retry the things that it failed. Otherwise, it'll continue in how the success works. Okay, so let me jump here real quick and just show you. One thing we did announce was we have Durable Task Scheduler. It's a new backend that's available for Durable. And if I go to here, so you'll see there's a new Durable Task Scheduler. I can click in. And what this is a managed backend for you for all of your Durable Functions capabilities if you don't want to use storage and you want some enhanced features. So now you can see the one I just kicked off is running. And if I click in here, you can see what state it's at. So you can see it got some destination recommendations, it created an itinerary, it got some local recommendations, and all of these are calling other agents. But the nice thing about using Durable is you get this history of what's going on. So you can see where it says what I was looking for. It also gives responses of where I could go. And so at each step along the way, you can get information about, okay, what did it do beforehand? What did it do afterwards? So you can imagine one of the difficult things you're going to run up against with agents is sometimes troubleshooting. And because the data can change along the way, you really want to know what data you got beforehand, what was the result afterwards. And with DTS, the Durable Task Scheduler, you get all of that information built in. And you can see we're stuck on an approval. So it came back with my trip. It's Galway. Awesome. All of this information is available. And now it's waiting for an approval. So again, you're using Durable. You're using one of those patterns that allows you to wait for an approval from an external source. And in this case, it's the client. Okay. Last couple of minutes. I'm basically going to kind of finish up. There's lots going on in this space, lots going on in the agent world. But the one thing I want to call out is everything we've done here in Functions, it's really designed for you as a developer to expose out and take advantage of the systems you already are familiar with when you're trying to build agents. But a lot of times you need to integrate into lots of other systems when you're building out these agents. And Logic Apps, if you're familiar with, there's a great kind of a demo session later on today that walks through all of the capabilities Logic Apps has to integrate into all those different systems and also call Azure Functions as one of its built-in activities. And so if you are stuck trying to integrate into lots of different systems, Logic Apps will give you that capability. And if you click on this code, it'll actually tell you, I think it's like 3:30, but that will give you the ability to go watch that demo and go deeper into Logic Apps. Okay, so let's kind of just finish up here. The three big takeaways I would say is all of us are trying to build agents. We're all trying to think about how do we take advantage of this really good large language model capabilities. And when you think about that, a lot of the power in agents comes through tools, because that's where you give it additional context to get more information, plus also give it the ability to fire off tools to accomplish their tasks. And so without those two things, you're really not going to get into an agent's world very easily. And so I think the challenge for most of us, and hopefully what you'll see out of today, is if you're trying to expose functions, you're doing complex capabilities inside of those functions, or you're trying to do real-time RAG, then Azure Functions is a great place for you to start to try to expose out a lot of these capabilities as you try to build out agents inside your organization. So again, thanks everyone for joining this session. Really appreciate it, and we'll see you next time.